Greetings. In this video, I'm deriving a formula in order to re-express the integral of the inverse of a function. So let's say I have the function f of x, classically, right? And then if I take the inverse of the function, it starts looking like this, with this minus 1 here. Although, of course, this does not mean 1 over f of x, it means the inverse function of f of x, the inverse f of x. And I want to take the integral of this. And the reason I might want to do this is, for example, sometimes I have some function, let me say whatever function a of x, for example, however I want to call it, dx. And if I want to take the integral of it, it is simpler, for example, to imagine that this is the inverse function of some function. And then I can use this, this scheme that I will now develop here in order to evaluate it. Because I will only need this function itself and the integrals of its inverse function. Alright, and the same goes here, that actually I will be able to evaluate the integral of this inverse function only using the inverse function itself without having to integrate the f inverse, whatever form this exact function is, and the integral of not the inverse function but of the original function. So that's what I'm doing now. Alright, so I can begin with using some substitution, namely I will say that x equals f of u. Alright, so usually it is quite a common thing that u is on one side explicitly and everything else on the other side. Here is a different. Here's x equals f of the u. And I can express u out by doing f inverse on both sides. This is just the f of u. So here was f inverse, by the way. I'm re-expressing this entire integral of it. But here I'm talking about the f itself before it was inverse, as is here. And so if I do f inverse on both sides, I will get f inverse denoted as such of x on the left side and f inverse of f of u on the right side, right? And f inverse of f, they cancel each other. So the only thing that will be left when f inverse is applied to this is the u inside f of u. And so now I have this expression that f inverse of x is u. So I can put the u right here. So instead of f inverse of x, it's u. And then instead of dx, I have to change the differential. And how do I do it? Well, I can use this equation, this one, and I can derive in respect to u. So x equals f of u, therefore dx over du equals f prime of u. I can multiply both sides by du, and dx equals f prime of u du as follows. Now I can replace this previous dx by f prime of u du, so f prime of u du right here. Now for a little moment I will delete all of this and remember it in a moment and write it here again just to be able to use it back after in a second. And this thing that basically u times f prime of u du is like x times f prime of x dx, right? And I can use integration by parts to evaluate this. By the way, this is an equivalent expression to this, but of course in terms of u. So let me say I'm doing the integration by parts to evaluate this. I'm using the standard scheme of integration by parts. I won't be commenting on the details because there's a different separate video only on integration by parts made by me a long time ago on this channel. So u v prime I will rewrite u times f of u because the integral of f prime of u is f of u minus u prime will just become 1 because this was u, take the derivative of it becomes 1. And v again is the integral of f prime of u, which is f of u du as follows. So the only thing that's inside this is f of u du. Now this can be further written as u times f of u minus the integral of f of u. Well, let's say capital F of u, right? And by the way, I said x equals f of u, but then after that f of u, but then after that also u is supposed to equal f inverse of x, right? And so I will put the u inside here. The u will be plugged into here. So u f inverse of x inside the integral of f. And what I'm talking about here is, of course, x is f of u. But if I use f of u and put it right here as the x here, well, I will get xu, right? And xu would be f of u f inverse of x. And that will be this thing, basically, and it will subtract it from itself, because this is f inverse of x times f of u, and this would also be u times x, that would be also this thing. So this would become 0 suddenly, but I don't want that, so I have to keep in mind that this is in respect to du, and I'm just rewriting this as capital F to denote is the integral of f, because if I only did in respect to x, well, there's x, this is in respect to x side, this is in respect to u, and it will be a little bit messed up in the way that on the left side, well, it depends on in respect to what I integrate. So I would like to probably integrate in respect to u, therefore it will be du here, but x du, well, that gets a little complicated, and du in here, then it indeed gets this. Alright, so it's easier for me just to write capital F, not care about these details or go deeper into it, just say the integral of fu is capital F, and then the u inside indeed can be substituted this f inverse. So this final expression is almost what I wanted to get to. I can delete this integration by parts now, and what I can do is I can finally rewrite this thing directly in terms of just f inverse of x and x itself. Alright, and the integral of f. But I don't have to take the integral of f inverse, I will only have to be taking the integral of the f itself. So in some functions, when I say this function, I'm taking the integral of it, but let's say I'm seeing it as the inverse function of something else, and it is easier to take the integral of that something else, then I can use this scheme that we just developed. Alright, so we're writing it into the final formula that showed useful here, or will show useful in a second, or actually won't show overly useful in the example I will give, because the example I will give will be one that can be solved in normal integration, far easier. But I'll just give this integration example to show that this formula that we got actually works. I don't have to use it for example that will actually be one where it makes more sense, but I can, because that would take more time, but I will take a simple function and I will show that this actually is an alternative in order to get the integral right here. So u is f inverse of x, and f of u is x. So I can write this x f inverse of x right there. So that is taken care of, and then minus capital F. Well, capital F, I will just write capital F still, and it's of f inverse of x. Because the capital F, it is the integral of the f of x, not of f inverse of x, but it's the integral of f of x. So in this scheme, it might mix up some ideas a little bit, and it might be a little confusing before being used for many times. It might be a little confusing in the beginning. Therefore, it's very important to pay close attention and be very careful about it. Alright, so finally, this is the final scheme that I got from it. And basically, it is the possibility to take the integral of an inverse function without taking the integral of it itself as a function, but just taking the integral of the original function it is the inverse of. In other words, one can take the integral of the function by taking its inverse's integral and then explicitly writing into this scheme also itself, like this. But in general, you see, I didn't have to take the derivative, the integral of f of this f inverse a single time. Once I have this scheme, I can just use a function which is f inverse of something, and I can use the original f, which was not the inverse, in order to get the integral. So let me give an example. Let's say my f of x, the original one, is x to the third power, and therefore the inverse will be the cube root of x as follows, right? So I can follow this rule. It says x times the f inverse. Well, the f inverse is the cube root of x. Just want to quickly show that it actually works the same way. Of course, this ends up being x to the 4/3 times 3/4, according to the power rule. But one can also use this. So the integral of the original function is not the cube root of x, but it's the x to the third. So it's x to the 4th over 4, but I have to plug it into it, not the x, but the f inverse. F inverse is this cube root, so I have to, instead of x, write the cube root of x, like this. Alright, so what this gives is x to the 4/3 minus 1/4, and this is x to the 4/3. So indeed, this gives one 3/4 x to the 4/3.